Hello, class. So sorry I'm not in today. I'm just not really feeling the best. Whatever bug is going around, I have seemed to have caught it. So I'm just going to make a video, and if you have any questions after this video, you've watched it, just please send me an email. We can kind of just do like a quick recap in class on Tuesday. Hopefully I'm back in class on Tuesday. So yeah. We're going to be looking at Intro to Parabolas, and I know I've already introduced it because when I taught you factoring, I really wanted you to understand the purpose of factoring. So a lot of this might seem like a recap and not really necessarily an intro, but that being said, the focus of Unit 4 is going to be on quadratics, okay? So we're going to cover some of the main key points of a parabola. So that would be like direction of opening, the y-intercept, x-intercepts, axis symmetry, vertex, and optimal value, all right? And where it is you look on graphing. So we are graphing now. It's not so much of as much algebra. All right, well, direction of opening. What does that mean? Well, that's this whole idea of like opening up, like does it look like a bowl? Or does it look like it's opening down? Like this, okay? So like this would be like opening up. And then if it was going like this would be opening down, all right? Like the ends are pointing down. So if we look over here, what are the first one? Well, this is a opening up parabola. And over here, this is a opening down parabola. All right, and what determines that direction of opening? Well, I've kind of already alluded towards this, all right, and we're going to get way more into detail in the later lessons. But if I gave you a quadratic equation, so in standard form, y equals ax squared plus bx plus c, it is this a term right here that determines the direction of opening or closing. So if a is a positive number, it opens up. If a is a negative number, it opens down, okay? It is that a value that determines the direction of opening up or down. All right, well, y-intercept. Well, the y-intercept, all right, if you think about a graph, this is your y-axis. This vertical one right here, this one right here. All right, so the intercept just means where does it cross this thing? Like where are these red points? Like where is that point? Well, the y-intercept occurs where x is equal to 0. Because if you look at this graph right here, if this is your x-axis here, the value of all of these points I have just kind of drawn right here, these all fall right at the origin where the x is equal to 0. So if you wanted to find the y-intercept, okay, so like let's give you an example. So let's say I gave you the quadratic y is 3x. I'll give it to you in standard form. Y of 3x squared plus 2x minus 3. Okay, something like that. Well, the y-intercept happens when x is 0. So that means you take that 0 and you plug it in for that x and that x right there, and you would evaluate. You say, okay, well, 3, 0 squared plus 2, 0 minus 3. So that results in just y being minus 3. So in this case, there would be a y-intercept for that quadratic at minus 3. Well, let's just do one more example. Let's say I gave it to you in factored form, okay? Let me do green line again. Green line. Well, if I gave you a problem in factored form, let's do more complicated. Let's do like 1/2 x plus 2, I don't know, like let's do 3 over 5 x minus 7 over 4. Okay, just lots of fractions. Fractions scare people. Well, this is a quadratic in factored form. Like this is factored form. Factored form. This was standard form, right? But like they're both parabolas at the end of the day. They're still parabolas. So if I wanted the y-intercept here, again, same thing. Y-intercept occurs when x is 0. So just take that 0, plug it in there for that x, and that x right there. So then evaluate. So that's y is 1/2, 0 plus 2, 3 over 5, 0, minus 7 over 4. Okay, well 1/2 times 0 results in that first bracket just being 2. And then the second bracket, 3 over 5 times 0, would result in this bracket being minus 7 over 4. Well, what is minus 7 over 4 times 2? Well, that means your y-intercept, in this case, is equal to, well, let's do it. Minus 7 over 4 would be the same thing as minus 7 over 2. So it would be minus 7 over 2. And now just the proper way to actually notate it, like if I asked you this on a test and I said, okay, well, what is the coordinate for the y? Well, the coordinate is giving you both an ordered pair of x and y. So it's when x is 0 and y is 7 over 2. So if I was to go back here and give you this coordinate, it would be 0 minus 3. All right, that is the y-intercept coordinate written as an ordered pair. So the coordinate, or the point, this is the point. The point, all right? If the question asks you for that. Well, the x-intercepts, this has been the focus, all right, of pretty much the entirety of what we've been doing so far. The x-intercepts, again, similar to that graph I just drew above, that's everything we've been doing. That's like when the graph hits like this, right? It's these points right here. It's those points. Or, you know, it could be a single intercept. It could be like this, where it just touches the axis. You know, I'm drawing only opening up parabolas right now, but you can have the same thing going the other direction too, right? Like it can go like this and go down instead, but you'll still have like the intercepts right here and here. So just as you thought about the y-intercept, just like we've been doing this factoring the entire time, well, these points right here, these x-intercepts occur when y is 0. So this whole thing you've been learning before is factor. To find the x-intercepts in quadratics, you factor. All right. Or algebraically, it's you take your equation and you set y is equal to 0. So you set y is equal to 0. So hopefully this is a review, but let's say I gave you a quadratic that was like y is in standard form, once again, like x squared plus, I don't know, I need two numbers, so it'll be like 2x. Let's just do a really easy one, like 1, okay? Well, if I put that in standard form, all right, well, you want to first factor it. So you want two numbers that multiply to 1 and add up to that 2 value. So that would be x plus 1 in this case, which is really just x plus 1 squared. So what this means is if I want to solve for the x-intercepts for this quadratic, I would set this value right here, just as we've been doing, equal to 0. 0, x plus 1 squared, and now solve for x. Square root, 0 is x plus 1, so that means you have a single solution at minus 1. And again, hopefully it's a review, right? That means your graph would look something like this. at -1, you have a solution right there, -1. So it's where your factors are. It's where your zeros are, okay? It's your x-intercept are your zeros, your roots, your solutions. All right, I know I focus so heavily on this, so I know this one's a little more of a review, but just really keep that in mind, okay? So when you are finding your zeros, your factors, your roots, your solutions, you are finding the x-intercepts. Okay. The new one, this new term, axis of symmetry. Well, the symmetry, what is symmetry means same, right? And if you think of like what axis means, like think about like where we use these words like the y-axis, or when we use words like x-axis, like that's like just a line, right? It's like a line on the graph. So what I'm asking you for in layman's terms here is a line that almost splits the graph into two equal or same parts. All right? So visually, what that means is like, let's say you have some graph like this, and this is your parabola, okay? That's your graph. Well, if you were to draw a line like this, and I should say same, by the way, sorry, and mirrored. Well, notice how your things almost fold on each other, okay? Your graph splits like this right here, this green line I've drawn right here, is your axis of symmetry. That's your axis of symmetry. It's the part that goes. And the key thing about this, okay? The key thing about an axis of symmetry is, one, it hits the parabola right at what we call, and again, getting to this vertex, maybe I should have done this one first, but it hits the parabola right at the vertex. It cuts through it in half, right at the vertex. And let's say this thing right here, this imaginary line, let's say there was an x, like it was at the x coordinate, I don't know, 5, okay? You would say the axis of symmetry, or AOS, is x equals 5. That's how you describe it. It is a line that has the x equals 5. It is a imaginary line. It's not actually a line on the graph. It's an imaginary, I can't spell, sorry, line that mirrors the graph, splits it in two. It is a vertical line. So up and down, all right? And it passes through the vertex. So those three things, okay? Well, I've already talked about this vertex right here. Well, the vertex of a graph. So if this is a parabola, let me just draw one more. And this is a parabola. Okay? Well, the vertex is like the point in which the parabola almost like turns around, all right? It's like the highest or the lowest point. Well, it is the highest or the lowest point. It's that point or this point right here. And what you would describe that as, right? Like if you were to look at this first one, let's look at number 1. Well, that is an opening down. That is an opening down parabola. Well, on an opening down parabola, these will go all the way. These will keep going down and down and down forever. They will keep going down and down forever. That's what those arrows there represent. They will never come around and turn back up like that. That just doesn't happen, okay? So what you can say is that this is actually your highest point. It will never turn around and come back up. This graph will keep going lower and lower and lower. But in math, what we say the highest point is, this is the max, okay? So on an opening down parabola, there is a maximum. Well, look over here. See how we have this point right here? Just likewise, these will keep going up and up and up and up and up forever. And on this one, we have an opening up parabola. And on an opening up parabola, all right, the parabola will keep going up and up and up till, I guess you would say, positive infinity. If you've never seen that infinity, don't worry. But it just keeps going up and up and up. Well, on an opening up parabola, you have a lowest point. But in mathematics, we say that as a minimum. A minimum. That's what that means. So the vertex, all right, the vertex is the max or minimum of a parabola. All right, but just as above, all right, it is also the x coordinate, all right, of the vertex is the axis of symmetry. So this x coordinate, let me just go back. This x coordinate, what do I mean by that? Well, those red dots I just wrote there, like they would have an x and a y coordinate, right? Like that point would have both a x and a y coordinate, just as this one would. This right here would have a x and a y coordinate. Like if this was right here, 3, and this was up here, like 4, that xy would be 3, 4. Let me put it up right here. That would be 3, 4. Right? Like if this was 2 and this was 1, that would be 2, 1. That would be the location of that vertex. So that means in this scenario right here, if the x coordinate is your axis of symmetry, that means your AOS, in this case, the AOS here would be x equals 3. This value. And it would be like this. Here, your AOS would be x equals 2. This value. And that's what it would look like. All right? So that's the main idea. And the x coordinate of the vertex is the axis of symmetry, and the vertex is either your max or your min, depending on if it's an opening up or down. Okay, so the optimal value, because we're going to get into a lot of word problems, okay, and they're going to be like talking about like optimize this, like give me the max profit, the highest point that the ball reaches. It's going to be like when you have like a throwing problem, a projectile problem, all right? Well, this optimal value ties into the vertex, all right? Just like the vertex, the x coordinate right here of the vertex, the axis of symmetry was the x coordinate. Well, the optimal value is your y coordinate of the vertex, all right? So let's give like a word problem, all right? Like, like let's say this was a projectile thing. So you have something like a cannon, okay? Like it has, let me see, I'm going to really test my drawing skills here. And you fire a rocket, and that rocket goes like this, and it flies through the air, all right? And it said, find the optimal height to like hit a target or something, or like find the highest point. Well, that would be right here. Like that coordinate would be right, that would be your highest point right there, right? That would have some y coordinate. Well, that right there, that is your vertex of this parabola I've drawn. That is your vertex. And because it is an opening down parabola, that point right there is also your maximum. And that maximum would have a x and a y, but it is a y coordinate that we're concerned with. So this purple point I've drawn here has both an x and a y value. So that right there would be your axis of symmetry. But you can think of that vertex really as like the x coordinate being your axis of symmetry and the y coordinate being the optimal value. All right, you wouldn't actually write down a test, but I just want you to see the similarity. Like, so if a question ever said, find the optimal value, you would be finding the vertex and then finding the y value. All right. So the notes here is that the optimal value is the max or the min. The optimal value is the y coordinate of the vertex. Okay? So there's some new terminology that I've thrown at you, and it's okay if you're a little confused on like some of these on optimal value, vertex, axis symmetry. We are going to see a lot of this, okay? So this is just an intro just to kind of give you, throw some of the terminology at you that you're going to be seeing through this unit. Always refer back to the sheet, all right, to these bullet points that I have created here on what they actually mean. But we will see them in practice throughout this unit, all right? So do not worry. The one that you should, I don't want to say worry, but the one you should know is x-intercepts, all right? Like this one should be very clear because we have just done so much, so much, all right? Now we're just going to put them into practice. All right. Hopefully I see you on Tuesday. If you have any questions about this, please send me an email, okay?